Okay, hello. This is the summary of the chapter 1 and chapter 2. My name is ch1, and I'm from electronics engineering. Okay, so let's start it. As you can see, there are so many titles. So at first, this is the first title, Introduction to Sensors. So what is a sensor? The device which can convert chemical or electric response into a signal that we can observe. And sense classification, sense includes three classification. First, chemical sensor includes measuring distance, mass, temperature, pressure. Physical sensor includes measure chemical substances by chemical or physical responses. Biosensor includes measure chemical substances by using a biological sensoring element. The nose as a sensor, the olfactory membrane detects smell chemicals and converts it to an electric signal which is transmitted to the brain via the olfactory nerves. So 1.2 sensors and biosensors definitions. Sensors and biosensors definitions. As you can see, there's 3 points: sensor, transducer, and actuator, and they're all important. Detects or measures a physical property and records indicates or otherwise responsive to it, converts an observed change into a measurable signal and put into action. And sensors come to two items. Chemical sensor, physical sensor, and chemical sensor can transform to biosensor. Incorporating a biological sensoring element connected to a transducer. Physical sensor transform means measuring physical quantities. 1.3 aspects of sensors. Recognition elements impart the selectivity that enables the sensor to respond selectively to a particular analyte or group of analytes. So as you can see, these two images commonly used recognition elements, unselective electrodes, and this substrates and active sites. And the bottom is enzyme. Transducers have 4 points: electrochemical transducers and optical transducers, piezoelectric devices, thermal sensors. So there are so many points we should remember and we should focus on. So next title, methods of immobilization. Methods of biological elements connect to transducers. Absorption on surface, micro encapsulation, convolute attachment, encapsulation, cross-linking. And as you can see, this is performance factors of electrochemical biosensors. So there's several some advantages. Cost effective, does not require sophisticated equipment for storage can be integrated with a mini and professional is the interface with a smartphone, and the Internet of Things will expedite diagnostics and therapy optimization. And next title is viewpoint, and there's so many points. Design of a concept affordable, so there are some aspects features and something like that. And this challenge of smart sensing platform for biosensors. And there's areas of application, healthcare, and 3 different ways: offline, real-time monitoring in the food and beverage industry, and precision farming, gardening, vegetarian science, and mining. Okay, the next chapter is electrochemical transducers. The introduction. There are 3 basic electrochemical processes that are useful in transducers for sensor applications. As you can see, that is the features, and that is features as process. And this, as you can see, this 2 image can indicate the cells and electrodes and how does it work. A metal electrode dip into an electrode solution, 1/2 cell to 1/2 cell. Okay, and this some equation that indicates the how this function works. Okay, the next chapter. The next title. The quantitative relationships. The Nernst equation. The basic Nernst equation. Is that, and for the half cell reaction, we have the second equation. The Nernst equation is as follows, because we have the above the equation, so we can infer the equation as follows. The Nernst equation that becomes that. So, and the last equation for the pH of mixtures of acids and bases. And this is the wall temperature and amperometry. These 2 images indicates the 2 equations: a linear sweep or thermogram, diffusion effective and electrode for a potential step reduct process. And this is the cyclic voltammetry, and these 3 images, as you can see, it described some way I said above, and scan of the potential as a function of time, the cyclic voltammogram of mole, and the mechanism of the voltammetric oxidation of the parent atom, the current time profile associated with a potential step redox process. And this is the username for this equation. So with the certain cell and each electrical combination, the delay in current reaches an approximately steady state after certain time. So this some equations about kinetic and catalytic effects. So conductivity. So we can infer the two equation to the final equation, E the a conductivity bridge, as you can see this image. So a typical diagram showing the frequency dependency of the imaginary impedances against the real impedance, and this image. And the next title is Field Effect Transistors, a classification of a material according to energy bands and interatomic spacing, the semiconductor band gap energy model from. Okay, the next title is formation of the junction between an N-type semiconductor and a solution containing a redox couple before contact. And this is the field effect transistor, and this is the inside structure. And yeah, and this is Q. So how does it works, the function and the inside electric structure? The next title is modified electrodes, thin film electrodes and screen printed electrodes. And this first image is a screen printed electrode, schematic of the Exatech biosensors disposable electrode strip. And this is an image of the microelectrodes, and this equation describe how does it works and how does it why the image is. So this is a thin film electrodes. Schematical of a tin oxide based thin film gas sensor. And this is the last title of metric sensors. Introduction, absorptions, a structure of a nicotinamide in its oxide and reduced forms. And this is the optical techniques, and this image is the electromagnetic spectrum. And this is the reaction mode of the luminol reprinted from biosensors. And this is the other image about that. So as you can see, this image describes the optics, how the optics transform an illustration of the total internal reflection in a single core optical fiber, showing the trajectory. And this is this is something to describe the optic transformation. As schematic of a solid state optical sensor and schematic of an optical sensor. Light scattering problem with different styles and detection wavelengths. And that's all. Thank you.